Hello everyone, in this class we are going to learn the static storage class in C programming. So let's start. Syntax is static, then data type, then variable name. This is the syntax of static storage class. Now that means this is how we can use the static storage class to declare variable with the help of this storage class. Now how system will work when we declare a variable with the help of static storage class, we need to know that thing. So whenever we declare any variable, the first task is allocate memory for the variable, and then system will initialize value. So first of all we need to know how system will allocate memory when we declare the variable with the help of static storage class. Look, in generally when we declare any variable, the variable is a global variable. At that time the memory is allocated from data section. But in case of static storage class, variable will be a local variable and then memory allocated from data section. What does it mean? Look, when we declare any variable in normal way, at that time if the variable is a local variable, for that local variable memory is allocated from stack section. But if a local variable is allocated with the help of static storage class, at that time memory will allocated from data section. And we already know whenever memory is allocated from data section, the initial value will be 0. That means in case of static local variable also, the initial value will be 0. That means this is the default value in case of static variable. Now coming to the next point, that is, if we declare any local variable as static variable, memory is allocated only for the first instance. Memory allocated for very first execution, and before allocate the memory, system will search to the data section whether the memory is already allocated to the variable or not. If memory is already available or allocated to the static variable, at that time system will no longer allocate memory for the static variable. Clear? So this is the scenario of static data type or static storage class. Now coming to the next point is this, using this static storage class we can solve the third problem that we face in case of function execution. The problem that we face in case of function execution is whenever we start execution of a function, system will allocate memory for the function. All the variables that are declared inside the function is allocated in memory, and when we come out from the function after execution of the function, all the memory will be deallocated. That means when we come out from the function, at that time the memory allocated to the function will be removed. That means no longer the function will exist in main memory. So if after come out from the function, if we need any information of that particular function execution, we are not able to get any such information. But with the help of static storage class we can solve this particular problem. That means using static storage class, multiple execution of a particular function can share some information. Clear? That means this particular static storage class will also useful to share information between multiple execution of a particular function. Clear? So this storage class will also helpful for sharing information between multiple function execution. Multiple execution of a function. Multiple execution of function. Clear? Now, let's take an example and see how all these things work. So, this is our program. This is our code segment. Now, we will see how system will work with this particular code segment. Now, look at here. We have two functions. One is main function, that is our entry point function, and other one is user defined function, that is fun. Clear? Now, let's take name as AB. So all these will be AB. So this is our entry point function and this is one user defined function, and inside user defined function we declare two variable. One is integer x, other one is static int y. That means x is a, here in case of x the storage class is auto, and in case of y the storage class is static. That means we declare one normal variable and one variable as static, and we will see how these two variable will behave in this particular function execution, and we execute this particular function for 3 instances. Clear? And we will see how static storage class will help us to share the information between these 3 execution of AB function. Clear? So let's start execution of this particular program. Now look, the first thing is x is local variable and memory is allocated from stack section. Clear? Y again a local variable, but local plus static variable. That means memory will allocate from data section, and whenever memory is allocated from data section, initial value will be default value or initial value will be 0. And here in case of stack allocation, the default value is garbage value. Clear? Now let's start execution of this particular program. Now we are in main function, that means inside main function, then the first function called is AB function. That means we execute this particular instruction from main function. That means control of program execution come out from main function and start execution of AB function. Now in this AB function we declare two variables. First variable is, look, all these are in stack section. This is our stack section and this is our data section. This is our data section and this is our stack section. Now system control of program execution comes inside the AB function and declare the variable x from stack section, that is inside AB function itself, and initialized with 5. And after that the next instruction is static int y. That means now the memory for this variable y will allocate from data section, not from the stack section. So the memory for variable y will allocate from data section. The variable name will be y and then initialized with, look, here nothing is specified. That means system will initialize with the default value. So what will be the default value in case of data section? The default value in case of data section is 0. So system will initialize with 0. Now coming to the next instruction. Next instruction is x plus plus. That means the value of x will increase by and become 6. Next instruction is y plus plus. That means here we are using the variable y, and when we use any variable, system first look in the local space, that means in the stack section. After that, if the variable is not allocated in stack section, at that time it will go for data section. Now as y variable inside ab function in stack is not declared, system will search for the y variable in data section, and in data section it will get the variable y. Now the value of y will increase to 1. The next instruction is this one. So what system will give us? It will print something. So what system will print? Print x equal to %dx. What is the value of x? The value of x is 6. Next is comma, then value of y equal to %d, the value of y. What is the value of y? The value of y is 1, so it will print 1. Now backslash n, that means coming to the next line. Clear? Now control execute all the instructions from this ab function for this particular instance of execution, and then encounter the closing brace. Now control come out from the main function. Now look at here. When control come out from any particular function, at that time all the memory spaces allocated to that particular function in stack section and heap section will deallocate by the system. But whatever variable we declared as static variable, all those variables will remain unchanged in data section. Clear? So which memory spaces are allocated to this ab function? This particular memory instance is allocated to the ab function. That means system will allocate this particular block from stack section and come out to the main function. And as we declare the variable y as static, that means the memory is allocated to this variable from data section, and hence this particular memory will not deallocated from data section when control of program execution come out from this ab function. Clear? Now we are in the main function, and in main function now we get the next ab function call. That means now again the next instruction is ab parenthesis. That means we are again calling the function ab. Now what happened? System will again come out from the main function and enter into this ab function. Again come out from the main function and enter inside the ab function, and memory is allocated for ab function in stack section. Now look at here. Inside this main function, integer x is allocated we declare integer x, that means memory is allocated for the variable x and initialized with 5. Now look, in this particular execution, this is the second instance of ab function execution, and in the second instance of ab function execution we lost the previous value of variable x, as x is a normal local variable. X is not a static local variable, but so as it is a normal variable, that's why system again allocate memory for this particular variable x. Clear? In the new instance of execution. Now coming to the next instruction. What is next instruction? Next instruction is static int y. Now system will check the data section whether this static variable y is already defined in data section or not. If already memory is allocated for y, system will not allocate memory for y in the second execution. So Now system will go to the data section and check whether the variable y is already allocated or not. The variable y is already there or not. Now look, variable y is already there, that means system will not execute this particular instruction and no more memory allocate for y in this particular AB execution instance. Now coming to the next instruction. In next instruction, system increment the value of x. So the value of x will increment to 6. Next instruction is increment the value of y. So increment the value of y to. Now next instruction is printf. So it will print the value of x. So x will be how much? 6, comma y will be how much? Y is 2. So now the value is y is 2. Next is backslash n. So control come to the next line in the output screen. Now again system encounter the closing brace. That means the execution of this particular AB instance is completed. That means all the memory allocated to this particular instance from stack section is again deallocated by the system. But still memory allocated for static variable y is not deallocated. Clear? Now control come out from this AB instance to the main function, and then inside main function we again encounter one more AB function call. So in this main function we again encounter AB function call. Now what system will do? Now again system will come out from main function. Now again system will come out from main function and enter inside AB function in stack section, not in the data section or heap section, in stack section. Now in this section again system start execution of the main function int x. Now int memory block will create for the variable x and initialized with value 5. Now coming to the next instruction, it is a static variable, so it will search in the data section whether the variable y is already present or not. Now it is already present, so system will not execute this instruction and no new memory will allocate for the variable y, because for variable y memory is already allocated. Now coming to the next instruction x. Now the value of x will increase to 6. Next instruction is the value of y will increase to 3. Coming to the next instruction, that is print. So it will print x equal to 6 and y equal to, now the value of y is 3. Clear? Now again control encounter the closing brace. That means again the third execution of this AB function is completed. That means control now come out from this function and enter into the main block. So this particular main function, this particular AB instance will deallocated from stack section, and then we are now in main function. Now in main function we encounter the closing brace. That means the execution of the whole program is completed now. Now what happened? Now system will allocate all the memory, all the local memory, all the global memory, all the static memory from memory. Clear? Whatever memory is allocated to this particular program, all the memory will be deallocated right now when the control encounter the closing brace for the main function. That means the whole execution of the program is completed. Now system need to remove all the memory whichever allocated to this particular memory, whatever type of memory it is. Clear? For which type of variable it doesn't matter, it will deallocate all the memory allocated to this particular program. So now when control of program execution encounter this particular closing brace, at that time which memories are available? This particular main memory is available in data stack section. This main function is available in stack section, and then in data section we have y static variable. That means all the memory is deallocated now, and the control of program execution come out from this particular program. Clear? This is how the execution of static variable and normal variable differs from each other, and this is how control works with static variable. Clear? Now in this particular program, if you observe the outcome of this particular program, look, each of these AB function execution instance, the normal variable, that is x, memory is allocated for this variable in each execution instance. Here for the first instance, memory allocated for variable x and initialized with say 5. Here also in the second instance, memory allocated for the variable x and initialized with 5. In the third instance also, memory is allocated for the variable x and initialized with 5. But in case of static variable, memory is allocated only at the first instance of the execution of this particular function. Clear? So when this AB function is executed for the first time, only at that time the memory is allocated for the static variable y, and in remaining execution, system just check whether the static variable is already defined in the data section or not. If it is already defined, then system will not allocate any memory for this, for second, third, fourth, so on, all the instance of execution. It will allocate memory only in the first instance of execution. Clear? So this particular instance used, this particular function instance allocate this particular variable memory, allocate this particular memory to the variable y. Now in this instance of execution of AB function, the same variable, same static memory, same static variable or same memory block for the variable y will used by this particular instance also. The third instance again used the same memory block for the static variable. This is how, with the help of static variable, multiple instances of same function can able to use the previous execution result of a variable. Clear? So this is how multiple instance of program function, multiple instance of any function execution can share any particular data. Clear? With the help of static storage class. Clear? So hope you understood the whole concept of static storage class, and it is very, very important for any competitive exam or even for any interview preparation. This particular concept of static storage class is very, very important. So if you are not feeling comfortable with the whole concept of static storage class, please go through the video again and again until you get comfortable with the whole concept. Clear? So that's it for today. See you soon in our next class. Thank you.